Welcome back, everyone, to the Xamarin Show. I'm your host, James Montemagno, and today I'm super crazy excited to have my very good friend, Jim Bennett, all the way from, I have no idea where you're living nowadays, cloud developer advocate here at Microsoft, who's coming on to talk about this awesome blog post / custom vision / we got BB-8 here. I'm super, what are we even talking about,
What
Jim?
do we even talk about?
Yes.
Yeah. We are talking about classifying images. So one of the cool new AI tools that's come out of the Azure Cognitive Services is an image classifier.
Oh, cool.
And it's a magic little tool. You teach it what something looks like, and it can then identify that.
Nice. So first off, Jim, before we get into it, maybe tell everyone a little bit about yourself.
Okay, so yeah, I'm Jim Bennett. I'm a cloud developer advocate here at Microsoft. This is my 4th week on board.
Nice.
I've known James probably for the last 4 years or so through the Xamarin community. I've been a Xamarin MVP and then a Microsoft MVP. Heavily involved in the community, the author of Xamarin in Action. The guy who wrote the foreword from that is a particularly nice chap.
I heard it's pretty good.
It's a pretty good book. And yeah, just super stoked to finally be on the show.
Awesome. Yeah, it's good to have you here. And I'm really passionate. Often I'm talking about machine learning and building models. I literally know nothing about it. So I have my good friend Frank, who does a podcast with me. He's the expert. He knows everything. And we've gone into all sorts of different details about what does it mean to make a model versus image, and how do you build like hot dog or not, essentially, things like that. But you did something way more interesting than hot dog or not. So maybe you can cue it up by telling people what you built and why you built it.
Okay, so what I've built is a little tool for helping to identify my daughter's toys. So I've got a little girl. She turns 5 tomorrow. So happy birthday, Evie, for tomorrow. And she's got a whole raft of different cuddly toys. And I lose track of what they're called. Even she does. She picks a name for her toy, and then she can't remember what she's called. She's called that toy. So I thought it would be great to build a classifier to allow me to use my phone to take a picture of a toy and it tell me the name. And that's kind of a nice idea for me. And also thinking that things like, we've recently moved to the UK, so you don't know where I live now, I keep moving around the world. Recently moved to the UK, we spend a lot of time with my parents who are based in the UK. They have no clue what her different toys are. So again, they could use this app to kind of sneakily learn that her favorite toy this week is called Baby Duck. So they can know. Yeah. That was kind of my inspiration for building this.
That's pretty cool, because then you could also take it to the next level, which is you could then start tagging it, right? You could create an app where not only could you scan the toy, but you could then create a database entry, right? Like, oh, this cost this much. This is when we got it. This is when we no longer was the favorite, right? Yeah. And kind of see trends. That's actually a really great idea.
It's great if you have other parents with kids and their kid likes your toy. Where did I get the toy? Take a quick photo, look it up. Oh yeah, we bought this toy in this particular shop.
So I assume then that you're a data scientist, you're like a machine learning expert and things like that, right?
Nope.
Okay.
Not in the slightest. As far as I'm concerned, this is a magic box.
Got it.
And this is one thing that's really cool about the whole Azure Cognitive Services, where I've been playing with them, is you don't need to be a data scientist. Now, I'm sure you could get someone like Paige Bailey on here to explain how it all works. I have no clue, but I don't need to have a clue.
Magic. I like when
it's
magical
all magic.
things.
It's a magic box.
Yes. All right. So what are we looking at? What do you have up here right now?
So what I've got here is the Azure Custom Vision service. You can get to it at customvision.ai and just log in with a standard Microsoft account. And from this, you can train a neural network to identify images just using a small number of images. So historically, you would need thousands upon thousands of different images.
Yeah.
And over time, you train this network to recognize certain things. What Microsoft have done, they've got some pre-trained images. I don't understand how it works. We've got some pre-trained images. You give it literally 5 or 6 pictures, and that's enough for it to learn that this is this toy, this is this toy. You think about a classic hot dog, no hot dog. You give it 5 hot dog pictures, 5 no hot dog pictures, and it can tell straight away which one is which when you take another photograph.
From my understanding, it's important not to have what it is, but it's almost more important to have what it's not, right? And because it's going to keep learning if this is not a hot dog, not a hot dog, not a hot dog, it's going to get really good at knowing what a hot dog is because it knows what it's not. Is that about correct-ish?
I believe so. It's called overfitting, I think. I'm still not 100% sure on how that bit works. I just rely on the magic box side of things.
So how would I get started here? What is this?
So to get started, you go to customvision.ai, you click on New Project, give it a name, my project, give it a description, thing, and then you choose the domain. So there's a number of different domains that these models have been pre-set for. So general means, I don't really know what it is, you can train it up whatever you like. There's a food one, which has been trained with food item. So if you're doing hot dog, no hot dog, apples versus oranges, That's a great one for that. They've got landmarks, they've got retail, they've got adult, which is great if you want to build content filtering. So you want to build a social media app or an image sharing app, and you want to make sure that people are not sharing things they shouldn't be.
Got it.
It's a specialist one for adult content. And you notice the bottom 3 are repetitions of 3 at the top, but marked as compact.
Yeah, what does that mean?
So that means these models are small.
Oh, got
Now,
it. Because
traditionally
models are like usually the biggest thing in the world. So how do you put that on a mobile device, right?
You can't do it. Yeah. So with things like CoreML and TensorFlow on Android, you can take these models and run them on device. They run on the GPU.
Got it.
So if you train just a normal general model, that runs in the cloud, where resources are bajillions of different specialist processors that run. That's really cool, but you can't do that on a phone.
Got it.
The compact model is not as good as the normal model, but it's still good enough for what you need, but small enough to run on a device.
And then
that is hugely important.
It starts compact, and I assume that you're building up the model because you're going to add a bunch of images to it, right?
Yes.
Got it.
Yeah.
Cool.
So I'm not going to create a new project. I'm going to use one I prepared earlier.
Okay.
So I've got one here that I use my daughter's toys. And I have loaded up not that many toys. So this is it. This is enough to do...
Porgs.
Yep, some porgs there. She does love her porg. We've got a
porgs.
cat, a cuddly duck, we've got BB-8, and we've got a cuddly tiger.
The question is the Porg or is the BB-8 the favorite currently? Like, did she see The Last Jedi?
She's too young for that. She turns 5 tomorrow.
But all we know is that the Porg is adorable.
She loves the porg. She got really upset the other day when she learned that porgs are not real.
Oh my god. Yeah.
Yeah. So I really want a real
Spoiler
porg,
alert.
Daddy. But no, sorry, they're not real. But yeah, this is all it took to train it. So you give it these pictures, and then you click the magic train button, and that's enough for it to go off and figure out this is what a tiger looks like, this is what BB-8 looks like.
What are these things on these tags over here? Because how does it know?
Right, so when you upload an image, you give it a number of images and you give it a tag, and that tag is what is in the image.
Got it.
So I uploaded this one here, which she calls Tiny Tig, and I've tagged it as Tiny Tig.
Got it. So immediately then it knows what's not the tiger because it doesn't have those tags.
Yeah, so this one here has got a tag of BB-8. We've got the porg here, she calls it Porgy, it's got a tag of Porgy.
Got it.
So the tags are what you use to identify what's there. You upload apples, you tag those as apples. You upload oranges, you tag those as oranges.
Okay.
So the tags are to say, when you learn what this thing is called this one is called this one is called this.
Okay.
That's kind of it, really.
So what does train do when you hit train?
So when you hit the train button, this will go off and this will take the half-complete model and then specialize that model based on the images that are there.
So if I was to get another toy, would I then upload and then retrain?
Yeah.
Okay.
So you'd upload more images, you'd retrain. Okay. And every single time you do a training, you get a thing called an iteration. So where are they? So you have these different iterations.
Okay.
So the very first iteration I had, I'd only trained it with 2 particular toys.
Got it.
And the next iteration I added another toy, and then I added a couple more images of a different toy, and then trained it again. So when you do a prediction, you actually see the images that you use for the prediction appear here.
Cool.
And I can say, well, actually, this one here, it predicts it was the porg, but I could then tag it. I can say, well, actually, yes, I definitely want to tag this as the porg.
So it knows.
So it knows. So if it's, especially if it finds one it doesn't recognize, I can say, this is this. Or if it's a new toy, if I were to take photographs of the monkey here, I could then add that one as a new toy and add a new tag.
Got it.
Then I click the train button again, it runs another iteration and learns more about
Oh, that's cool. So you can essentially keep training the model as you're using the model.
Yes.
Oh, that's cool. That's
yeah, because you kind of need to specialize the model. If you take a photograph of something and it doesn't know whether there's a hot dog or not, you say, yes, it is, no, it isn't, you train the model again. So you can keep the model growing and improving.
Got it.
And keep getting more specialized.
So how do I take this? I mean, it seems like here I could upload an image or something, but how do I get it in my app? Because like I care about putting it inside of a Xamarin app. So how do I do that?
That's what I care about. Yeah. So I mean, they do have this quick test thing here where I can just choose an image. This is an image I took earlier.
Okay.
And this, sometimes it doesn't come back straight away. Oh, it did. And then I clicked browse one more time. So shouldn't take very long to come back. There we go.
Cool.
100% probability it's BB-8. So everything's probability based. It doesn't say, I think this is X. It says, here is a probability that it is this tag, this tag, this tag, this tag.
It's pretty good. It's 100% sure it's BB-8.
100% sure it's BB-8. And it's never seen this image before. So now if I go back to predictions, you will see the image appears there. And I
Got it.
train it.
You can go and tag it.
Yeah. So that's cool, but obviously it's more fun in a mobile app.
Yeah, because you're going to be around, the grandparents are going to be around, you're going to be around, they get a new toy, you're going to be tagging stuff.
Yes.
Yep.
And actually, it is really, really easy to get this in.
I like easy things. I'm a big fan.
Yep, it's a NuGet package.
I love that.
Literally, there's Microsoft.cognitive.customvision.prediction. It is a NuGet package. You bring that in. You then create an instance of a prediction endpoint. You give it an API key that comes from Custom Vision. You call predict image, and you pass it a stream. And that stream contains the image. So if you were to use, for example, the media plugin that you've written, that spits out a file. You can then get a stream from that. You pass the stream in here. So
what is this hitting? Is it hitting an endpoint, or is it what's happening? When I call this predict image, what happens?
So behind the scenes, when you call predict image, it will go off to Custom Vision, pretty much exactly the same as when I did the quick test.
Got it.
Upload that image up to the endpoint. So obviously you have to have an internet connection. It'll then run this in the cloud, download the results.
Okay.
You can see straight away. So if I just run this on my phone here, we should be able to hopefully, if the demo gods are with me, we can see it in action with BB-8 there.
And so this is going to go through, and then this returns this. What's an image tag prediction model? Is that something you created, or is that coming back?
So this comes back as part of the API. So as part of the NuGet package, we have these prediction models. They contain the name of the tag and the probability. So when we predict, we get back, in fact, let's take a breakpoint here so we can see it. So if I just run my app here, I will take a photograph of BB-8. It's all using the media plugin. Upload that. We hit my endpoint here, and it's going to go off the cloud, do its thing, come back, and then I really should have.
You've simplified your code
I've simplified code too much. I can't see what's going on. But if I run this, I
don't know what it is.
Don't know what it is. Let's try this again, and let's actually use the front of BB-8 this time. Problem is, these models don't understand what it is. They understand images. They understand different colors. So there we go. Probably because of the black eye on the front there. So let's bring that up there. It's found its BB-8.
So can you go and add a breakpoint then to see the result there if we do it again? So you're calling this from somewhere, this get best tag.
Yeah. So, you know,
so I'm really interested in what's coming back.
Yeah.
There we go. Oh, okay. Interesting.
Look
at this. We're refactoring code live. I like that.
That's the way to do it. Refactor it live. Okay, let's take a breakpoint there.
Yes.
And let's run this again, and we can see what actually comes back.
Yeah, because to me what's interesting is I'm really interested in the results of what actually literally just happened. So, so here though, you get some predictions, and then this just seems to be super easy code. And then you're just using a link essentially. And your query is like, I want to find the highest probability, or what are you determining for the?
So I want to find the highest probability.
Got it.
Essentially, it's that. I've got a threshold on here.
Oh, okay.
Because I could end up taking a photograph of like you, for example, and it thinks there's a 0.1% chance that you're BB-8 and a 0.05% chance that you're a porg.
Yeah.
And so
high probabilities as well.
That's the thing. I don't want that to come through. I want it to say, I don't know who you are.
Got it.
So I've got a threshold set at 50%. So I'm just going to run this again, take the same photo, and we should hopefully now hit this breakpoint and we can see what comes back. And essentially what comes back is the same as we got from. There we go.
Okay, so 5 predictions.
So 5 predictions. So the first one has a probability of 1. So it's a double, it goes from 0 to 1, 1 being a 100% chance. And it comes out with the tag BB-8.
So that's the tag that we saw in the custom vision. Oh, okay.
Yeah, and there we go. The porg is 1.4 times 10 to the minus 17% chance.
That one always throws me because you got to go back to your math class, right? Because it's actually exponentially to the negative 17. So it's like, it's basically 0. Let's be honest.
Yeah, pretty much 0. And again, tiny tig, it's pretty much 0. Baby duck is pretty much 0. And baby mama.
So do these get returned in specific order or random from your findings?
They're in the order of the tags.
Oh, okay, got it.
So the way I have my tags defined here, it does it in the order that the tags were originally added. As far as I know, things may change.
Try my face. Let's see what happens on my face. I'm ready.
Yeah, okay, let's try it. So
the beard, maybe the beard will be a porg.
Okay, let's see what it says. I hope it comes up as a porg.
I'm excited.
You're excited. Okay, so what have we got? Oh no, I think it does come back in the order of probability because there is a 2.3 times 10 to the minus 6 chance that you are a porg.
Not bad.
You are going to be the next Star Wars film. Well done, you. And 5 to the minus 12 that you're a tiger.
Okay, cool.
And then 4 to the minus 13 that you're a small cuddly cat. And then 3 to the minus 13 you're BB-8. So the closest it thinks you are is a porg, but you're looking at 2 times 10 to the minus 6. So it's a very, very small probability you're a porg. So what will happen here is I will filter out based off a probability threshold and say, I don't know who you are.
Got it.
You're not 50% or something.
Now this required an internet connection to make that connection. What if to me, what if I'm in a place, I'm in the middle of a cabin in the woods, I don't have internet connection, I still want to do this. Is there something that the Custom Vision AI gives me to do that? Because I know that built into both iOS and Android, I have, like you mentioned earlier, you have CoreML, which is core machine learning from Apple, and then TensorFlow, which is Google's essential version of that. So like, do I get to use those, or do I have to go reinvent the wheel?
Yes, you very much get to use those. So that's one thing that's very cool about the Custom Vision system is you can export your models.
Ah, okay.
So when I look at my iterations, you'll see there's an export button at the top here.
Ah, I like that.
Choose this, iOS 11 CoreML, Android TensorFlow.
Okay.
So I can download my models. This is why I went for a compact model. If I went for the non-compact model, I wouldn't be able to download it.
Because it'd be so big, you can't really upload a gig app to the App Store anyways.
Yeah,
so
I think there's a limit like 500 megas of the model size for CoreML. I don't know about TensorFlow.
So this model here, you download it. Now the nice thing, I'd assume that since Xamarin gives you direct bindings, are you then just using the CoreML APIs themselves? How does that work?
Yes. So I have got another version of the app here. And as part of this, I've built a NuGet package, a Xamarin plugin, for making this really, really easy.
Oh, cool.
Because it's kind of quite hard if you don't know how these APIs work.
Yeah.
So on iOS, what you do is you download the model. You then have to compile it. It comes as an uncompiled version. You have to compile it. I don't really know why. I'm sure there's smart AI people who can tell me. I get this model, and then what you can do is I load it. So everything's all written for you. All the APIs are there. There's a whole lot of CoreML APIs are based around Vision, which is in the VN namespace, I guess. You've got VN CoreML request, which is a request that makes sense CoreML for Vision access. It's all asynchronous. So literally, I get the image. I take the stream that I get back, I convert that to a UI image. I then pass that to CoreML request, this VN CoreML request, which is designed to identify things inside images. It's pretty much built for this particular purpose.
Got it.
And then it has a handler that calls back to return some results. And these results are essentially a list of classifications, which are tag probability pairs.
Yeah.
Kind of identical output, different class type because it's iOS API, but essentially the output is the same. Now, one thing to note about this is there's 2 CV pixel buffer. So these models don't actually understand images. They're not about images. They just understand raw binary data.
Ah.
So it doesn't look at an image.
The ones and zeros of the image, not the image itself.
Yes.
Yeah.
And it expects an image to be a certain size. So Custom Vision works on images that are 227 by 227. So I have to convert it to the right size. And then I have to convert it to essentially a pixel buffer, just a whole lot of floats, a whole lot of floating-point numbers for RGB. And then you pump that in there, it runs the neural network, does the magic in the magic box does, and then spits out your tags and probabilities.
Oh, cool.
And that's really cool. And then on Android, it's the same thing. So there is a TensorFlow inference library, which is the equivalent of this vision-based CoreML library, which is designed for processing images. It's been wrapped, it's been bound, there's a Xamarin binding for it. It's not available as a NuGet package, it's just up on Git at the moment. It's this TensorFlow Xamarin package.
Oh, cool.
And I'm using that in my code. And pretty much it's exactly the same. I have a bitmap, an Android bitmap. I scale it down to 227 by 227. I spit out a whole lot of floats. So pretty much I'm just building a big byte array of, well, float array essentially, with floats for RGB values. I feed it in. I run the model, I fetch the output, I get some outputs. The difference between the models for iOS and Android, CoreML has the tags built in, the Android one doesn't. It just knows that the 0th item has a probability of X, the first item has a probability of Y. But with the model you get a labels file. And this labels file just gives you the labels for the tags. So you know that the 0th one is going to be the first label, the one that's going to be the next label.
So it's kind of nice. So if I have an internet connection, I may want to use that because that model might be updated, right? Because literally, I mean, the nice thing is if you're offline, what you're saying is not only can I use TensorFlow, can I use CoreML to actually get it so I can be completely offline, but if I use the online version, I can continually rapid iterate, and then also my model online may be better than the model here. So would you recommend then a strategy of maybe checking first locally and then going online, or what would be the best strategy? Like combining the two or one or the other?
It It depends.
Okay.
I know it's a standard cop.
Because I'm assuming the CoreML is going to be way faster than making a web request, right?
So the advantage of using CoreML or TensorFlow is you can do it over a live video feed.
Got it.
So one great example I've seen for this, I saw a demo at NDC Sydney last year where they were using ultrasound scans to look for bladder defects in babies in utero. So as they're doing the ultrasound, they'll see a certain defect if you know what you're looking for. And a model was built just to very quickly identify these. Now, if you wanted to have that as a constant live feed, so you've got the live ultrasound feed, and as you're doing the scan, if it spots it, it pings you straight away.
Yeah, it can't be making web requests every 5
It can't be.
seconds. Yeah.
And if you think, if you're a big flash hospital in America and the sort of the first world, you have radiologists who know to spot these things. If you're out in the middle of Africa, for example, so you're a very generic doctor, maybe Médecins Sans Frontières, and you're helping to train up the local midwives to do ultrasound, if you've got an ultrasound plugged into an Android tablet, you can't make those internet connections to do the scan. So you can put the model on there.
You can be Doctors Without Borders, you're going out, you're going to scan something, you do it right on the device.
Yeah, and you don't need to necessarily train everybody to look for everything. It's this device will find it for you, and if it spots something, it will ping one of us and we can come and actually investigate further.
Yeah.
So it depends on what your use case is. If you want to have a live video feed, you probably want it on device.
On device.
But if you want to continuously improve the model, then you want to have it remotely. But of course, you can always just re-download the model.
And redo it. It's nice that you can mix and match, so you can kind of get it all together. Well, that's awesome. I love it. I think it's a really cool use case, more than just hot dog or not. And all the source code on GitHub, or how do we get it?
Yep. So all the source code for this is up on GitHub. We can put it in the show notes. The NuGet package, we'll
put it in the show notes
put it
below.
in the show notes below.
Awesome.
It's all there, and it's so easy to use.
I love it. It looks easy. I really like it.
Yeah,
awesome, Jim.
2 lines of code, image is recognized.
Well, thanks for coming all the way over to show off this custom vision AI. I love it. I'm going to go become a machine learning expert now. So, well, thanks again, Jim, for coming on.
Thank you for having me on. It's been awesome.
Yeah. And thanks, everyone, for tuning in. This has been yet another episode of the Xamarin Show. Make sure you subscribe up over there, down there, ding the bell. You know what to do. Subscribe so you get all the latest episodes right in your inbox and feed each and every week. So until next time, I'm James Montemagno, and thanks for watching.